Yes guys, we're back again with another menacing looking integral, but shouldn't be a problem for us. We've got integrate from 1 to pi minus ln pi, ln x plus inside the ln, and so on and so forth forever. Now, notice I said forever. So we notice that obviously we can't actually integrate this using any normal techniques. So the first thing to know is that, look, we've got ln x plus da here. Then we have ln x plus da there, and so on and so forth and so forth. Now we can say let y equal ln x plus ln x plus ln x close bracket, another close bracket. Now notice how this part here is also ln x, so we can say y equals, this implies y equals ln x plus y. So now our integral we can rewrite as, let's put I at the beginning, I equals the integral from x equals 1, x equals pi minus ln pi, y respect to x. Now the issue is, right, we've got our bounds in terms of x, our integrand in terms of y, and we're integrating with respect to x. So obviously this is not going to work. So what we need to adjust is anything in terms of x should go to y. And from there, if we can do that, integrating should be a piece of cake for us. Let's go. So first thing I want to adjust is the dx. So dx, let's just put a line on that. So y equals ln x plus y. Now to get a dx, we sort of want to separate the, well, not sort of, we actually want to quite clearly separate the variables. So let's raise each side to the power of, to base e, and rearrange for x. Now we have to do e to y minus y. We've got x in terms, we've got x on one side, y on the other side. So if you differentiate both sides, let's say with respect to x or y, say with respect to y, dx over dy is now our left hand side. E to y integrated is obviously, so differentiates e to the y, and minus y becomes minus 1, which is all good. So this should become dx over dy. Now obviously we're after dx, so we can simply times through by dy, and we have e to the y minus 1 dy. So let's put a box around this. Alright, so if we go back to our integral, this is checked off. Now we just need to adjust the bounds. So if we write in bounds, so we have x and y, so 1 and pi minus ln pi, and y we know to be, let's run side, y equals ln x plus y. So when x equals 1, y equals ln y plus 1. And just by testing a few values on our head, we can see that, well, ln 1 equals 0. So when y equals 0, this equals true. So 0 equals ln 0 plus 1. 0 equals ln 1, and this checks out to be true. So y equals 0. And for pi, ln minus pi. So let's put that in. So let's say when, that was when x equals 1. Now when x equals pi minus ln pi, we have y equals ln pi minus ln pi plus y. Honestly, we can't really do much with this, can we? So let's make it simple for ourselves. Just raise each side to the power of e to the y. pi minus ln pi plus y. Okay. Now what would work? So we need to get ln pi somewhere, and we need to have pi. So I'm tempted to think that the y value here would be in terms of ln. So y equals ln pi. So let's put that in ln, pi, ln pi. Let's see what happens. We put that in, minus ln pi plus ln pi. This becomes pi, cancel, and that checks out. So y equals ln pi. Now, right, that's our bounds adjusted, so let's put a box around that. So if we go back to integral, bounds have been readjusted, so we can rewrite this integral now as a equals the integral of pi, what was it, ln pi 0, and we had e to the y minus 1 and multiply by y, so y e to y minus 1 dx. Expand our brackets, y e to the y minus y, this should become dy instead, dy. Now to integrate this we'll have to use by parts, so let's come over to the side. Y is easier to differentiate than e to the y, and e to the y we integrate just e to the y, so let's use a tabular method for this. So we have 1, 0, e to the y, e to the y. So that becomes ln, actually, y e to the y minus e to the y, and then we minus, obviously 0 times e to the y, that's fine. Okay, that's our di method done. Now we need to evaluate integrate minus y, so minus y squared over 2. Then we have ln pi and 0. Okay, now all we need to do is just sub in our bounds, but before we do that, let's just take out e to the y here. Minus y squared over 2, just for ease later. So let's sub in ln pi, so we have e to the ln pi minus 1 minus ln pi all squared over 2, subtract, now plugging in 0 for y, e to the 0, which just becomes 1, 0 minus 1, so that's minus 1, minus 0 over 2, so that's minus 1. So all of that just becomes plus 1. So for e to the ln pi is just 1, ln pi minus 1, so ln pi minus 1. Sorry, e to the ln pi is actually pi. Then minus ln pi squared over 2 minus 1, so just plus 1. Can we simplify this any further? Pi, so we have minus pi there. No, pi ln pi, no. So we can safely say that that is our integral evaluated. Nice job.